Okay, so let's go ahead and tackle the pendulum now. And the way that we're going to think about this is the pendulum's arm is going to be the our mover's orientation plane z-axis. So uh, like we have over here, we had balls on the end of the, or spheres on the end of the z-axis for our planes. We're just going to keep that sort of set up and work from that. So we have force of gravity. We've already written it into our code over here. I changed the name of this, and then we already have it here. So we need to, what we're looking for is acceleration. So we need to put something in here to calculate acceleration. So we have force of gravity, we have the pendulum. For the, if I kind of skim over anything, just know that we're using, just whatever I skim over, assume that I'm using the orientation, or that I'm using the unit vector. So like with the length here, I'm just using the unit vector to calculate it, but then to represent it in grasshopper, we're using different variables. So if that was confusing, just ignore what I just said. So we have force of gravity, we have this, the OP z-axis, and we want to get the force on the pendulum. This is 90 degrees here, so all we have to do is a little bit of trigonometry where the sine opposite over adjacent, or opposite over hypotenuse. So we can have, we know theta and we know gravity, so we want to get force of P, so just so opposite the force of um, the pendulum is over the force of gravity equals sine theta. So we have this equation here, and we can get both variables on this side. So that gives us the force of P. And what we're going to do is we're going to rotate vector towards vector by angle force of P. So rotate, we're going to rotate our orientation plane z-axis towards the gravity axis by an angle of FP. So that's going to rotate, a little bit. So that's going to give us our acceleration angle, or acceleration orientation vector. And so we're going to remap that to the world because we want those orientation vectors in terms of the world. So let's go ahead and write this out. First thing we want is theta, and we're going to get that by rs vector angle gravity vector and our self dot orientation plane z-axis. And so we're going to plug that theta into this equation up here, and I'm just going to leave this FP so it mirrors what we have written here, and then we have gravity times, and then this gets a little bit confusing, or not confusing, gets a little bit dense here. We have math sine, and then we need math dot radians. I think radian or radians. Radians. And we're going to put theta in here. So we need to import math, and then also while we're at it, we're going to import our vector methods that library that we wrote quite a while ago. And we're going to rotate or import that as VM. So the math takes care of the math, and then VM rotate vec towards vec by angle. So that we're going to just say VA for that vector of acceleration, and so VM dot rotate vec towards vec by angle, and the angle that we are going to rotate from is going to be the self dot orientation plane, the z-axis. We're going to rotate it towards our gravity vec by an angle of FP. And then we're going to remap this to the world. So this is going to give us our self dot OV of acceleration. Up here we're going to update it to whatever this is remapped. Remap point, and what do we remap point? Vector, and then reference plane, target plane. So the vector is going to be the VA. The reference plane is going to be our self dot orientation plane, this plane right here in the picture. So we're going to, and then the plane, our target plane is going to be RS world XY plane. So that gives us that, and this is in terms of the world plane, so that's what we want. So that takes care of that. Let's see if we get any bugs. We're not getting any bugs. We don't need acceleration anymore because we're not dependent on that. So let's run this and see what happens. Okay, so it's working how we want it to, and this this down here is our pendulum, and then this is the velocity. So this represents the velocity, but it's in terms of the z-axis. So we're going to leave it there for now, and then come back, and I'm going to set it up so we can look at all three: acceleration, velocity, and position all at once.